All right. Okay, so this is study guide, and I have sent it to you already, and now this is the solution that I'm going to explain to you. So problem 1 is very simple. Find the equivalent resistance between point A and B. So point A is here, point B is here, in the following figure. So in this little circuit, not a complete circuit, A and B, I need to find the equivalent resistance for this guy, right? So in the upper branch you have two resistors, 2 ohms and 2 ohms, and in the lower branch it has 2 ohms. So obviously the top two are in series, and then those two are in series is parallel to the one at the bottom. So these two are in series to each other, and these two are in parallel with this one. So I want you to find the equivalent resistance. Alright, so let me show you the solution. So I have redrawn the figure. So now I call this, just give it a name, R1 and R2, and this is R3. So after I find the equivalent resistance of the top two, I should end up with this figure, where instead of R1 and R2 separately, I will have R12. R12 is R1 and R2 in series, so I use a straightforward formula. R12 is R1 plus R2, so 2 ohm plus 2 ohms, so the answer is 4 ohms. That's why I get R12 is 4 ohms. But it's not done yet. Now I have this R12 in parallel with R3. So then I have to find the equivalent resistance of these two in parallel. The formula for resistors in parallel is 1 by R123 is 1 by R12, that's the top one, plus 1 by R3, the one at the bottom, this one. So R12 is, as we found, it's 4. R3 is given 2 ohms. So I get 3 by 4. 1 quarter and a half. Add them up, half plus a quarter, you get 3 quarters. So to get R123, then I have to flip it. Don't forget, you have to flip this R. Then you get 4 by 3 ohms. Okay? So now the equivalent resistance between point A and B is now R123, which is equal to 4 by 3. So that's the end of the problem. So it will be multiple choice, so you have to make sure you get the answer correctly. Alright? So that's number 1. Now let's look at number 2. So they are all simple short problems. And number 2 is this. Just a second. Number 2 is find the equivalent resistance between points A and B in the following figure. So now the extra thing is this one is this 2 ohm is in series with this little loop. In this little loop I have 3 ohms and 4 ohms in parallel. So first of all you have to find these two in parallel. After you get that, then that will be in series with this 2 ohms. Alright? So there are 2 steps that you have to do. So let's look at the answer for number 2. Excuse me. So I call it R1, this is R2, R3. R1 is 2 ohms, R2 is 3 ohms, R3 is 4 ohms. So in order to find the equivalent resistance between these two, because they are in parallel, I have to use this formula. 1 by R23 is equal to 1 by R2 plus 1 by R3. And R2 is 3 ohms, R3 is 4 ohms. So the common denominator is 12. 3 goes into 12 4 times, 4 goes into 12 3 times. So I get 7 by 12. but to get R23 I have to flip that. I get 12 by 7 ohms. Then after that it will go in series with R1, which is 2 ohms. So I know R23 now, which is 12 by 7. R1 is 2 ohms. So I just add them up. 2 plus R23 is 12 by 7. So common denominator is 7. 2 goes into 1 goes into 7 times, so that's 14, plus 7 goes into 7 1 times, so that's 12. So 14 plus 12, that's 26 by 7, and 26 by 7 ohms. Okay, so that's the answer for number 2. Very, very simple. Alright, so now let's look at number 3. So now number 3 is a complete circuit. I have this little circuit, so see the same shape here, and then there's a little battery, and R1 is 2, R2 is also 2, and R3 is also 2 ohms, right? Each of them are 2 ohms, 2 ohms, 2 ohms. And V is given as 12 volts. Now, again, I have to find equivalent resistance of these two, and then find equivalent resistance together with this one, right? The same method that we use in number 2. So be careful. In the exam, the figure might be different, right? I might have a different numbers here, or different shape, or different things parallel at the bottom or at the top, whatever, but the method is the same. When they are in series, you add them up. When they are in parallel, you use 1 by R is equal to 1 by R1 plus 1 by R2, that sort of formula, right? Okay, so now I have to solve this circuit. So this is for problem 3 to 8. I use this figure. So problem 3, 4, 5, 6, 7, 8, they all come from this figure. Number 3, find the equivalent resistance between point A and B. So from A to B, exactly the same way like we did in number 2. So if we do that, let's see. So now I have R1, R2, R3. I don't put the numbers yet. So this R2 and R3 in parallel. So I use this inverse formula. 1 by R23 is equal to 1 by R2 plus 1 by R3. This one, see, is equal to R2 is half, R3 is half. So half plus half, you get 1. So R23 is just 1 ohms, because when you invert 1, you get 1. Now I have to add to this one. So R123 is R1 plus this thing in series. So R1 plus R23. R1 is 2 ohms. R23 is 1 ohm. We just found that. So 2 plus 1, I get 3. So the equivalent resistance between A and B is just 3 ohms. Okay? Now number 4. Number 4 says that find the current going through resistor R1. So what is the current going in here? Well, obviously the current going in R1 is the total current, but once it gets here it will split. But the thing is, the question asks you the current in R1, so all you need is finding the total current, and so that will be the current going through R1. So let's see. So when we do that, then I know that I find the equivalent resistance between point A and B. That is R123, and this is V. This is the current I. So I use V is equal to IR. V is this V, I is this I, and R is obviously R123. By the way, this is R. V is equal to IR is called Ohm's law. So V is 12 volt. I is the one I want to find. R123 is the one that we found in the last problem, which is 3. So then 12 divided by 3, I get I is equal to 4 amperes, right? Amperes. So I get the answer. Current in R1 is equal to 4 amperes. Now number 5. So what is number 5? Let me show you. Find the voltage drop through R1. So now I want to find the voltage drop through R1. So voltage drop, what is voltage drop? Well, again, Ohm's law, V is equal to IR. And so if I want R1, V1 is equal to I1 R1. Let me show you the figure again. V1 is the, sorry, not this one. V1 is the voltage drop in resistor R1, and the current is I going through that. So that'll be, I call it I1. So V1 is equal to I1 R1, or just I R1. I is 4 ampere, R1 is 2 ohms, so I get V1 is equal to 8 volts. Okay, so let me look at this figure again. What this means is that this V is 12 volt, and there's a current going through, and then after it goes through resistor, the first one, this one, then the voltage drop is by 8 volts. So only 4 volts left. This is 12, then here you waste 8 volts, right? So to go through from here to here, you have only 4 volts left now. Okay, so that's a way to see that. So to find the voltage drop from the loop, then V is equal to V1 plus V23. V23 is V minus V1 from here, and V is 12 volt because this V is 12 volt. V1 we just found that it is V1 is 8 volt, so 12 minus 8 I get V23 is 4 volt. So what it means is that you start out with 12 volts here, you go through R1, you lost 8 volts, so to go from here to here, that is voltage drop through these resistors is 4 volt now, right? Okay, so it's 4 volt. And now number 7, in question 7, the question is find the current in R2. So I need to find the current in R2. So the current has 2 branches. Once it gets to this loop, one is going through upper link, next one is going through lower link. So this one is 2 volt, this one is 2 volt, and the voltage drop from here to here is 8, and from here to here is 4. We just did that. So what is the current in I2? Well, V is R2, V is equal to IR again, V23 is equal to I2 R2. V23 we just say that it is 4 volts. R2 is 2 ohms, so I can find I2. I2 is 2 amperes, right? So now let's see if it is reasonable. So you see, going through this is, we know that its total current is 4 amperes, that is I1 is 4 amperes. We found that. I don't want to write here, but the current is 4 amperes. Now it's going to split into 2 halves, upper branch and lower branch. Now we know that R2 and R3 have the same resistance, 2 ohms and 2 ohms is given here. 2 ohms, 2 ohms. So if the current comes here, if the resistance is equal on both sides, then obviously it will split equally, right? So current is 4 amperes, then it will go through 2 amperes here, it will go through 2 amperes here. Okay, so our answer is reasonable. We got 2 amperes. Now the next one is we need to find the power dissipated in resistor R1. So obviously P is IV. So now in this case is I1 V1. I1 is 4, V1 is 8. So I get 32 watts. I can also use this formula, P is equal to I square R. So I becomes I1, R becomes R1, I get the same answer. Similarly, I can also use P is equal to V squared by 2. V this time is the voltage drop in R1, and V1 squared by R1, I get 32 watts. So, doesn't matter which one you use, you get the same answer, 32, 32, 32. Alright? So now let's go to the next problem. The next problem is something to do with Kirchhoff's rules, and I'm going to use this diagram. The question is very easy. No numbers. Look at this. There's a junction A. There's a loop on this side, a loop on this side, and then the big loop. So there are 3 loops altogether, right? The loop on the left, the loop on the right, and the big loop. There are 3 loops. I already indicated the direction of the current. I call it I1 going up, I2 going up, I3 going up. All of them going up. Okay? That means I1 is going into A, I2 is going into A, I3 is also going into A. Alright? And R1, R2, R3, R4, and there are voltage sources, and there's V1, V2, and V3. Right? So the question is, write down the junction rule for the currents at junction A. So, as I said in lectures, the current going in must be the same as total current going out. So, in this case, the current going in, let me split this. The current going in is I1 going in, I2 going in, I3 going in. I don't draw the whole thing. I1 going in, I2 going in, I3 going in, I1 plus I2 plus I3. Nothing is going out, so on the other side it's 0. So if you get that, you get full points. Now, question number 10. Write down the loop rule for the left hand side loop. So I do not draw the whole full circuit. I just draw the left hand loop. So I copied the left hand loop here. V1, I1, current is going up. R1, so it will be going to the right, and then here I2 is going up. This is V2, R3, and in here it will be I1 because it's the same wire, you see, from here to there. Okay, so there's dot dot dot, that means the other side of the loop. So I start from point A. This little circle I gave you for your help. So this is I am traversing the circuit, this loop, clockwise, right? I'm going clockwise. Counterclockwise means going like this. Clockwise means like this. See, 12 o'clock, 1, 2, 3 o'clock, 4, 5, 6 o'clock, and so on. So that's clockwise. So from A, I am going in the same direction as the current. So I write minus I1 R1. I am walking in the same direction as the current. Now once you get to this branch, I am going from long to short. So it's minus V2. Short to long will be plus. And then I come down. I get to R3. Current is going up. You are walking down. So opposite direction. So I write plus I2 R3. Then you keep on going, and then you get to V1 minus to plus, so I get plus V1. Short to long, so I call it plus V1 is equal to 0 because I get back to A. Now let me show you something. Here, instead of walking clockwise, let's suppose I walk it in the opposite direction. Let me draw the circuit again. Only half the circuit, right? So it will be not the whole circuit, but only this loop. So there's dot 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 is on the other loop, okay? And this is V2, R3, this is V1, This is I1 going up R1, and this is R3, and so I2 is going up. So instead of walking clockwise, let me walk counterclockwise like that. In that case, how would you write this equation? Well, start from point A again. I go like this. Now this time I am going in the direction of the current is to the right, but you are traversing backwards, you see. So instead of going towards R1, I should be going down. So I start from A, I'm going downwards now, because see, I am traversing counterclockwise. So if I am going down, then I see long terminal and then short terminal, so I get minus V1. Come down, I'm walking counterclockwise. Come down here, then go up. So I'm now in the same direction as the current I2. So it will be plus I2 R3. Oh, sorry. In the same direction as the current, so minus I2 R3. And then I get short to long, so I get plus V2. Then I get to here, I'm going to the left. So now the current is I1 coming to the right. So then I'm going opposite to the current. So I get plus I1 R1 is equal to 0. So it looks like it's different from this, but they are identical. Look, all they are different is the sign. If I multiply this whole equation with a negative sign, I get what? If I multiply this whole equation by minus 1, I'll get V1 plus I2 R3 minus V2 minus I1 R1 is equal to 0. So you see it's exactly the same equation. This one and this one are the same. V1, V1, I2, R3, I2, R3 minus V2 minus V2 minus I1, R1 minus I1, R1. So if you know how to write that, you will get 4 points. Okay? Alright. So this is it. And if you study this, you will do very well in test 2.